this morning we started to see the basics, so the transmission media, which is the fiber. We will try now to have a look on how to use them, because everything was explained by Alain, of course, is amazing, but then you really need to pump inside data and to be able to take them out at the other end, in between, or whatever, these kind of things. So you already seen that the building blocks for these things are the cable, the connectivity. But I think we try to make a step further, which is to propose solutions. We don't even think that this will be the best solution, but it's just a starting point for you to think. We think these are already quite good, but I think the beauty of some of them, and you will discover later, is exactly that it's just when you buy a box of a Lego, the construction game, you have generally a shape to make, an airplane and a ship, whatever. But then the nice thing is that you play yourself. This is a bit what we have in mind when we design our product, to have something which is very flexible. And this, I hope you will appreciate later on. In general, we decided to link the things in a brand name, which is RetractaNet, to recall the fact of access, because most of them are mainly applied for the access network. Access also, we think that excellent, but this will be your judgment later on. I will not go through all of them because it's going to be too heavy. But we will concentrate on two system solutions, which go under the name of RetractaNet and Verticasa. But altogether, and you will understand why, go under the name of retractable solutions. Why retractable? Let's say that until now, the majority of let's say, the practice uses the cable and access the cable from one end. So generally speaking, you have a cable, you lay the cable. When you arrive somewhere, you need to open and take the fiber outside. There was already something to make the mid-span access, but again, you need to remove all the, basically you need to have the cable as it was at the end. So you need to remove the sheath, take out the tube, etc., etc., etc. Thanks to the fact that at the moment, technologies like the flex tube, for instance, they don't require the cable to be stranded. What happened? It happened that the cable itself is just a cylinder with the fibers inside. So why not to open on a side the cable and being able to pick up the fibers? In fact, you have seen already some of the pictures before. And so based on this concept, what we try to propose? We propose the fact that you open a window, you cut the module, and then you open another window and you pull the module out. It seems sort of a magic, and to be fair, we didn't believe it was possible. A little story about this is that to reinforce the fact that we are quite open to listen what the customers are saying, especially after this occurrence, it was that there was a French operator, not an incumbent, an open mind guy. They just wanted to deploy quick an optical network. And they came to us and they said, we want fibers available in a duct. We said, sorry, impossible, because the fiber, you need to protect them, you need to put the gel, you need to put the tube, blah, 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 blah. And they said, okay, we are new in the field, you are there since 100 years ago, you may be right. Then the nice story is that they went to Draca. At the time, we still were two different companies. And Draca said, okay, let's have a try. And after that, a race started to work in this direction. And the beauty of this story is that then the race ended up to something which is successful. You will be probably a bit overwhelmed in the next 2 hours, but with the food in between, about this story. You will see some movie, you will see the real life of these solutions. To summarize the concept, more than my words, let me use a short animation. So in this application, we are direct buried. So somehow you open a trench, you install a cable, you first see that you don't need any loop anywhere, so the cable is down. When you need to give a service down there, you have to open a second window downstream, cut, simply with a cutter, retract back the fiber. With or without the tool, we will also see that this is going to be not needed anymore. And then, simply by pulling the module, you get to the home. So, simple as that. No splice anymore, if you don't want. No splice anymore in the field. Take the fiber out and use it. No matter where the houses will be built in the future, you still have fibers in your duct available for use. Sometimes when the line is very straightforward, you don't even need to open a second window. You just pull back your module, and the game is done.
How far approximately can you pull back?
Let's say standard is, we started with 25 meters. Now in a straight line, we extract up to 200. Because in the end of the day, also the force to be applied is not much. And especially, I mean, after maybe the first fiber can be a bit tighter, but then the second, third, the cable is getting empty. And this is why it's exactly because of this ease of extraction that if you are making a street with single dwelling homes, sometimes you don't really need to open the second window, but you just cut everything and you scrape what you don't need. Well, so the RetractaNet will be then the outdoor application, and Verticasa will be the indoor. To finish the story between Prysmian and Draca, that was also the fact that in parallel, always following this operator, which in the end is Free Telecom, we progressed in parallel, and now getting together as a two company, we really have the total expertise for this kind of application. The cable. So the cable, as I mentioned, they wanted a duct. To be precise, they wanted a rectangular duct because they were close to what you install cable trays inside the building. But for us, cable manufacturer, which work with extrusion lines, the corners we don't like because it's a bit difficult to extrude, to bend, to put in a drum. So in the end of the day, we came back into a circular shape. It seems a bit oval here, but just because of the screen. And you see the fiber are laid inside. They are quite loose, of course, because you need to have the space to retract. And as well, you need to leave the space to this cutter, to the blade of the cutter, to enter and not to damage the fiber. This must be somewhere, but anyway, later on we can see and discuss during the break. This one is not a rocket science item, even though I have a patent on it, probably the only one in my life, because this is the potato peeler, basically. It's the one you can use to peel the skin of the potatoes. A bit reinforced because we're a bit more thick in this case, but it's exactly the same kind of story. The important is that the blade, when it enters the cable, will be parallel to the fiber. Don't grip on them. So once you open the window, you need to just close it and protect a bit what's inside. From this display, that probably some of you can see better than others, but you see that the box itself has the scope of just protecting against the mechanical potential injuries. In this particular case, also water sealing is IP68, but the evolution of this in the Netherlands, where they use massively this kind of application, is they don't care about the water. Because the fiber, we saw this morning all the theory about the coating. The fiber today is still sensitive to the water ingress and the vapor, but the protection of the fiber itself through the coating, then through what you can say, the insulation, the buffering that you have around, is enough that this kind of fiber could live, we made a lot of tests, could live in water until it's not damaged or broken. They can live more or less forever in water. So in the end of the day, the risk has been shifted a bit, not anymore to the fiber, but to your house, because you can imagine that in your house you have a pipe like that coming in your basement, and this is somehow broken, and the water comes inside. Sooner or later you will swim in your basement, which is probably not what you want to do. But anyway, you see also the dimension, because we are talking, this morning we talked about the miniaturization. This is already a reduction, because here this is for 288 fibers. This is still less, because you don't even need to splice, you don't need things for splicing. If you need something to splice, there is another solution, which anyway is still comparable in dimensions. And you can see that thanks to the little band radius, also the splice trays are shrinking more and more. The application for that was born as an installation in sewers, but then has evolved into duct, into direct buried, and in even aerial. Aerial was the last challenge we faced, because aerial, the aerial cables has to face a severe environment, which is made by the ice, the vibration, the wind, whatever. But we've been able finally to get also up to there. So now, after we understood the concept, which in the end I could have done in 2 slides, let's have a look on the application outdoor, which goes under the name of RetractaNet. You have mainly two basic schemes of using the cable. Always you first lay the cable on. I want to repeat again the fact that you don't need any loop. Means you don't need any pit. I mean, you don't need any very detailed planning, because you can really face the building of a new house, and you just simply open a little window, extract your fiber, and you serve the fiber. While if in a standard practice with loose tube, you need to face, there are little room to leave the slack of cable, etc., etc. So once the cable is there, you prepare the connection to the home you want to connect with a drop tube. Something like that is a 5 mm tube with a pre-installed rope, and you will see why you need a rope. Then, after cutting here, the retraction is made, and the module is redirected into the home, and the splice is made a house. Splice, maybe fusion splice, mechanical splice, depend on what another point is that there are in the market some, let's say, very, very strong based habits. Sometimes there are sort of a religious war. So people they want to splice, people they don't want to splice, they want to do mechanical. We tend to stay out of this kind of disputation, so that all our products in general are designed to have at the same time fusion or mechanical. But anyway, back to the story. You see, whatever you want to do, you make the operation of splicing at home, with the implication that maybe we can see later. So you have to stay at home for a longer time. You need to bring inside the home device. You may make a bit of dirty that the owner of the home doesn't like to have. So this may be your evaluation. The alternative anyway is there, apart from the fact that you can repeat this on demand. The alternative is that you may want to access your cable only from one point. We have a tool which I may find here down there, sort of a fishing stuff. You can imagine how it works. Here you enter from one end, you don't need the second windows, and you are able to cut at a distance more or less of 1.5 meters your module. The module is then retracted. You see there, The module is retracted. A drop cable at this time has to be installed from the home to the box, back there, and the splice and the connection is made here inside. These are the two approaches that at the moment are more common in the market. To be fair, the very 95% is made there. Because even though this seems a bright idea, at the end of the day, the application proved to be much easier and quick in this part. These are a return from the field. As I said at the beginning, we like to check what we think on the paper from what the field is telling back to us. And then, of course, the operation can be repeated. The next bunch of slides is to show the reality, the real life of this system. So first of all, we're starting in France, as anticipated before. That was a point-to-point network that they wanted to install in the sewers of Paris. This is definitely the champion of this technology. At the moment, they have installed something like 3 million fiber kilometers. The majority in Paris. You cannot believe how you can put underground in one single city so many fiber kilometers. But in fact, if you think that the cable is 720 fibers, you immediately understand that such amount is made quite quickly. That was the basic architecture and was driven by a few constraints. The first one is that here, as we said, Free was not the incumbent operator, so they didn't have any infrastructure. So either they started to dig everywhere in Paris, an impossible adventure, either they had to find something. Luckily, they could enter into the sewers, but the sewers has some kind of special constraint. In particular, you cannot enter in and out the sewers anytime, so you need a permission. You need to pay every time you enter. You cannot just throw the cable inside because there are strict rules for cleaning, for such kind of operation or maintenance. So for them was mandatory that the cable was compact, would have been compact, and would have been installed quickly, and then they didn't have to re-enter the sewer possibly anymore. And that's why they wanted a cable, as I said before, a duct with the fibers inside. If you think that this is a cable 720 fiber, which was in the region, out of my memory, of 25 millimeters, while the standard technology in loose tube would have been more in the region of 30 and more. Taking into account as well that you pay the rent of the space per square millimeter to save 5 millimeters in diameter was a lot of money saved. So what happened? They installed this. At the time, they wanted 25-meter retraction as a standard, because every 25 meters, more or less, they could have found an abduction pipe to get on the street floor. So they made all the extraction. They wanted to close with this kind of closure and bring out, without splicing here, and bring out the coil of the 25 meter of module ready, either in a pit, either directly in a basement for a later application. Because again, they didn't want to connect 100% of the customer at the beginning. That would have been too much expensive. So they found this kind of break-even point, which proved to be effective. And that was the main adventure and the main deployment, which has proven this kind of a technology was reliable, because unfortunately for us that we had to think about it, that was one of the more harsh environments you can think, because you have, in terms of sometimes pressure, humidity, difficulty of entering the infrastructure, and also the fact that the retraction was tested for the first time. So we got a good trust, and we went ahead. This second plant, which is probably the second largest deployment of RetractaNet is in a complete different environment. So in an easy one, we are in the Netherlands, soft soil, 30 centimeter depth maximum, even though because if you do more, you go in the sea directly. For here, we have a movie. We have a little movie that was made by Jack when he went to Europe to train. So it was shot with his iPhone, I guess. Not too much professional, but you can really feel how it works.
Nereye gidiyorsun? Yapsana. Sen biliyor musun kafadan? Nerede? Nereye gidiyorsun?
You see that the installation is made with very sophisticated tools. Is it what is crochet? Do you call it? No real protection. It's raining. You see, it's raining, so waterproof. Again, no need to ring mark or meter mark the cable. You just counting 1, 2, 3, 4. These are 2 fibers, but in this specific one, you have 2 fibers and 2 dummy. So in the same side, you can put 4. We can go up to 12, just in case. Then the fiber is, they install a little metallical bead just to be connected, you see later, to this part. They remove a rubber cap just to avoid the water when you pre-install. We go inside. No special splice, just crimp. Then you whistle to his friend, which is smart, much smarter. He stay under the roof because it's raining. Quality control, record. Of course, here we cut. There is a longer version. It repeated this operation 2 times because from one box you can have 2 drop tube. And you see that in this particular case, they decided to extract everything at the day 1 to leave it coil in a little space close to the home. So the day the customer is willing to pay, so you start having your payback, you really make the connection. You see a very straightforward longitudinal street. So basically, in this case, they didn't have to open the second window. They just recall the module. All this story is more or less 6 minutes per 2 homes. So 6 minutes to install the 2 houses. To see, during the coffee break, you can also practice, but just to see how actually it's easy to make the opening. Tack, and that is done. Yeah, then you can cut everything during the lunchtime. We can
Train some rodents.
of course, you see that as the cable has not loop, all the accessories will have the ability to go behind. So also in this case, the cable will be laid into the trench, so you must be able to go around, close, and work. And this is, of course, the philosophy that you have to apply for everything. If also I wanted to, because the picture, of course, is a picture, but in the reality, you see that the fibers are very loose inside. So if you do like that, they're coming down. But I remember one of the first presentations I did of this system, I was not very used to much. I opened, I said, you see, this is a cable. And all the fiber went into the public. But it was a bit embarrassing at that time. But you learn. Well, then after these two, we also tried the application in duct. So this is a typical urban environment. I don't know what happened in Australia. For sure, in Italy, in Europe, this is the kind of mess. Probably this is a tidy one, where in the edges, cables, there are layers of cable of everything. You get lost. You see that to find our own, you had to zoom, because in the end of the day, the space we occupy is really the space of the cable plus the closure itself. I don't want to read this busy slide, but just to see that we try also to make a comparison. And sometimes the time you gain is a lot. 20 minutes per se is nothing, but you think it's more or less 2/3 of the installation. As I said, on aerial, we were a bit afraid at the beginning, because aerial cable, when they're laid, when you have ice, you have a deformation, or important deformation, means that the cable can be elongated, and the fibers inside has to follow. So the construction with the stranded tube generally avoid that when the sheath is elongated, the fiber will suffer any stress. Then with a better fiber, and anyway, the right construction of the cable, we've been able to solve also this one. And you see that actually the solution was not was just to use a figure-of-8 cable. Again, why? Because sometimes I'm amazed by the fact that we are in an industry which are probably at the leading edge of technology innovation, the telecom, but we are conservative. Everybody, I mean, the industrial people, the customer. I mean, when we need to change the type of a screw, we generally decide, no, it's too difficult. We need to train everybody. So when possible, we like to maintain the standard practice to make the process of a transition quite smooth. So you see, these 4 pictures are nothing but the fact that they are standard practice when you install an aerial cable. The difference is a bit more into the protection, into the closure. If you will have the chance to have a look later, you see that in the end of the day, the closure is a box. You have nothing inside, but the only thing you need to take care, so the control of the bending, because even though the fiber is bending sensitive, you cannot crash. So the only thing is when you make this kind of bending inside, you will have to be sure that during the time with potential movement of the fiber itself, you may damage for the future the performance. But having said that, for the rest, the closure is installed as a standard one. This one is to show that, in fact, someone trialed. We developed the tool for the single access. The trial was successful, but if I measure the number of connections made in this case, honestly, I have to say that has not been very much extensive until now. The last picture showing an application in direct barrier. You see, this I wanted to show because the one you saw in the one you saw in the animation, it exists actually, is a sort of a controller of the tension and a coiler for the extra length. But you have seen in the real life the guy in the Netherlands that was throwing everything in the grass, grass, it would have been already a luxury, the grass, in the mud, and then he put it inside. Okay, I think for now I covered what I wanted to tell you. I will leave the stage to Jack again, that will tell you a bit about something we do here in this region.
Okay, thanks, Alessandro. Okay, so if FlexTube was a different type of cable and very different to conventional smart core, for example, then RetractaNet is a completely wacky design. I mean, it's completely unlike any other cable that I've ever seen on the market. The modules themselves take up about 50% of the space within the cable. That leaves enough room to make the window cut without any fear of cutting the fibers inside. You'll notice that there's a stripe on the cable. That's to designate the position of the strength members that are embedded within the sheath at either side. And so when you make your window cut, you make sure not to cut through those. You position those blue stripes on either side, just leaving the orange face visible for the cut. So as I say, the modules are free and loose, as you've seen probably through the samples. There's no water blocking materials within the cable itself. So you can almost think of this cable as a duct with miniature cables inside, giving you the ability to pull them out where you need. It's very much a fiber on demand type of system where you can access your fiber and not when and where you need it. The board here shows two forms of RetractaNet. The top one is its purest form, I think. You have two windows. You cut the module at one, pull back, and then use that module to lead into the customer's premise using the lead-in drop tubes. That's definitely one architecture that's worked very well in the Netherlands, as you saw in the video. The second one at the bottom here shows the splice variation, where you can splice to any type of drop cable that you may think of. We've even put the one that NBN are using for their multi-ports. There's an option that you could do something like that as well to keep a connectorized element to the system. Certainly these aren't the only two cases though. I think when you're talking about an innovative solution like this, to create the best solution for our customers, it would require a bit of dialogue, a bit of understanding of what their struggles and challenges are, and probably to build something unique and tailor it to that customer. Definitely, by working with customers, I think we could unlock the potential of this product. As I say, it's unlike anything else I can think of that's on the market. In terms of what we're doing in Australia, we understand that this product has got to be tailored to a pit and pipe environment, which we have the majority of in Australia. So for that reason, we've built a pit and pipe test site at our factory in DY. So this is a test bed that involves a number of pits linked by two 50mm conduits. The black boxes here are the pits in various different sizes, and we've laid some RetractaNet cable across the test site. And this has given us a feel of how the cable would work in a pit and pipe environment when it comes to retracting the elements and handling the cable. Certainly, there's still some further development that could be done with the tapping boxes to make it more suitable for that environment. As you can imagine, it's a little bit difficult working with a tapping box when it's positioned inside the pit. But we've got a few ideas and things that we're going to trial to make the solution more adapted to this style of network. The other thing we're looking to do is to take some real-life data from our customers and look at how we could really unlock the potential of the solution and just where the gains are in terms of speed of rollout, the number of connections you could make, and the cost of the system. So in that case, we'd need to look at some real-life data, do some proper modelling, look at the designs to realise where we think a RetractaNet could work the best. We certainly understand that it has great potential, but we're looking to really see whereabouts in the network it would work the best. So that's what we're doing locally. As Alessandro has mentioned, it's a design that's coming out of Europe. It certainly worked well in the direct buried installation in the Netherlands and in the systems in France as well. And we're really keen to leverage off that experience and to bring it to Australia as well. So if you have any ideas and want to speak to us a bit more about the RetractaNet solution, do come and pick our brains. Myself and Alessandro will be around, especially over lunch, to answer any questions.
What's the sacrificial sheet that everyone in Australia wants?
A nylon, yeah. So there's a couple of terms there. At the minute, this is not a nylon sheath, okay? There's no reason why we couldn't put an extra layer of nylon around the cable and still have an indicator for where the GRPs are positioned. And as you saw, the tool works in such a way that an extra nylon layer wouldn't be a problem when it comes to generating the window. Another thing, we could permeate the sheath with an anti-termite chemical, which has been known to sort of repel termites. So that's another option if we didn't want to go down to the nylon route. But I think nylon would work quite well with the reduced friction during installation as well that gives you. So yeah, that's what we're really talking about, is adapting the solution we know that works in Europe to the Australian climate, the Australian challenges. So.
Yeah. As long as the termite that didn't sign an alliance with the black rat, because one can open the sheet and the other enter. So they can
Teamwork.
Teamwork.